this, as you can see here, we are going to discuss about the positive clipper circuit, okay, which is used to remove the positive half cycle from a AC signal. So this is the circuit diagram of a positive clipper. Here first, this is the input AC signal, okay, consisting of both the positive and the negative half cycles. Then we have a resistance, okay, we'll come to it. Then we have a diode which is connected in this fashion, and then a load resistance R. Now this resistance is used to protect the diode from excessive voltage or current surges, okay. It is used to protect the diode so that it does not break down and get damaged because of excessive voltage surges of the input signal, AC signal. So this is the circuit diagram of the positive clipping circuit. The diode is connected. As you can know, this arrowhead is the P-type end and this bar is the N-type end. We have already discussed about that. And the output is obtained across the load resistance R. So here the normal basic concepts related to forward and reverse biasing of diodes is utilized. Okay, let us see how it is done. During the positive half cycle, means this half cycle, this end is positive and this end is negative. As you can see here, the positive end, okay, is connected to the P-type end or the arrowhead, while the negative is connected to the N-type or bar of the PN junction diode. Now you know that when a diode is connected in this fashion, it behaves as a forward bias diode, and when a diode is forward biased, it behaves as a short circuit. So this is the equivalent circuit of the diode during the positive half cycle. Okay, this entire diode, it behaves as a short circuit. So this is a short circuited terminal. Now as this terminal becomes short circuit because of the diode getting forward biased, the output across the load resistance is 0 volt. Now 0 volt means the entire positive half cycle is removed because we get 0 volt output during the positive half cycle. Means during the positive half cycle of the AC signal we will get 0 output. Again, let us repeat. During the positive half cycle, this end of the circuit terminal becomes positive and this becomes negative. The positive terminal is connected to the P-type end of the diode, while the negative terminal is connected to the N-type end. So because of this, the diode behaves as a forward biased diode. Okay, it is forward biased. As a result of that, it is short circuited. We know that a forward biased diode behaves as a short circuit. So because of the short circuited diode, these two terminals, they get shorted. Now we know that the voltage across a pair of shorted terminals is 0. So the voltage across the load resistance will be 0 volt. So during the positive half cycle, okay, the positive half cycle of the input AC signal, the output will be 0 volt. Now this means that the entire positive half cycle will be removed from the output. Now let us discuss the behavior of the positive clipper circuit during the negative half cycle. So as you can see, this is the negative half cycle. During the negative half cycle, this upper terminal, it becomes negative, while the bottom terminal becomes positive. So here we have the PN junction diode with its P end connected to negative and the N end connected to positive. So we know that when a PN junction diode is connected in this fashion, it will be reverse biased. Okay, so the diode will be reverse biased during the negative half cycle. So as the diode is reverse biased, it will behave as a open circuit. So these two terminals, it will get opened up. It will behave as a open circuit because of the reverse biased diode. So whatever the input voltage will be given at the input terminal, the same input voltage will appear at the output across the load resistance. So the output will be exactly the same as the input. Now the input is the negative half cycle. So we'll get exactly the negative half cycle of the AC waveform. Okay. So as these terminals they get opened up, the same input which is being given to the circuit will appear across the output through the load resistance. So the output will be exactly the same as the input, which is the negative half cycle. So during the negative half cycle, this becomes, the upper terminal becomes negative and the bottom becomes positive. So because of that, P being connected to negative and N being connected to positive, the diode will be reverse biased and will behave as an open circuit. And as a result of that, the entire input will appear across the output, across the load resistance, and will be exactly the same. The output will exactly be the same as the input, which is the negative half cycle. So this is the mathematical analysis of the positive Clipper circuit during both the positive and the negative half cycle. As we know, during the positive half cycle, the diode becomes short circuited, and because of that, the voltage across the load resistance is 0 volts. So there is no need of any mathematical analysis during the positive half cycle. Now it is the negative half cycle that we are interested in. So as you can see, during the negative half cycle, this diode is reverse biased and gets open circuited. Now if you look closely to this circuit, because of the open circuited diode, the resistance R and the load resistance RL are now in series with the input voltage, the input AC voltage. So whenever you get a circuit arrangement like this, you can apply voltage division rule to determine the voltage across any of these resistances. Now we are interested in determining the output voltage across the load resistance. So we can apply the voltage division rule here to calculate the output voltage across the load resistance. So we apply the voltage division rule and we get the output voltage as V0 is equal to Vi into RL by R plus RL. Now, the value of resistance R is generally less than the load resistance. So because of that, the addition, this value is nearly equal to the load resistance. So when we simplify, we get the output voltage is the same as that the input voltage. Okay, so this is how we get the output voltage nearly the same as that the input voltage. So here is the input and output waveform comparison of the positive Clipper circuit. So this is the input signal, which is a normal AC signal or a sinusoidal signal, as you can see, consisting of both the positive and the negative half cycles. Now as you know, this is a positive Clipper. It means the positive half cycles of the input AC signals are removed. So as you can see in the output, during the positive half cycle of the input, okay, the output is 0, output is absent, or the positive half cycle is absent. But during the negative half cycle of the input, the output is the same as that of the input, which is the negative half cycle, exactly the same shape as that of the input. Then again, when the positive half cycle appears in the input side, the output is again 0, or the positive half cycle is absent. Again, during the negative half cycle, the output is the same as that of the input, which is the negative half cycle. So in the output, the entire positive half cycle is missing. Okay, the entire positive half cycles are missing, only we get the negative half cycles. So that's why it is called as a positive Clipper circuit, because we are removing or clipping or cutting the positive half cycles from the input AC signal, and we only want the negative half cycles. Okay, so here we have discussed about the positive Clipper circuit. In my next video, I will discuss about the negative Clipper circuit, where we will clip or remove the negative half cycles of the input AC signal. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics and instrumentation engineering. Have a great day. Thank you very much.